Have you ever thought about printing electricity? Well, imagine a big machine. Usually a printer puts ink on paper. But what if a printer makes solar panels instead? You just roll the paper out, you put it on your roof, it catches the sun and makes power. This is not a science fiction dream. This is happening right now in real factories.
Welcome to The Explainer. Today we are looking at a very exciting new technology. It's called the Perovskite solar cell. This new invention will completely change how we get energy. Let's see why everyone is talking about this amazing science.
Okay, let's dive into this. Here is our simple plan for today. Section 1, a new solar cell. Section 2, why it is better. Section 3, the big weakness. Section 4, Japan's secret advantage. And Section 5, the global solar race.
Section 1. A new solar cell.
So what is it? A Perovskite solar cell, or PSC, is a new type of solar panel. It uses a special crystal called perovskite. The most amazing thing is this. You can melt this crystal into a liquid ink. Then factories can print it exactly like a newspaper. You don't need heavy, thick glass to make it. This technology started back in 2009. Professor Miyasaka invented it in Japan. At first, it made very little power, but by 2012, its efficiency crossed 10%. That was a big deal. Scientists around the world started to study it very hard. Now, look at 2025. Commercial sales begin. Companies are finally ready to sell these panels to the public. Think about old silicon panels. They are heavy, they are hard, they are very rigid. You can only put them on strong roofs or open land. But the new perovskite panels are completely different. They are light, they are thin, and they are soft. Section 2. Why it is better? Let's look at the benefits. First, it bends easily. You can wrap it around a round building. Second, it works in normal room light. Third, it's very cheap to make. And fourth, it can be colored. You can make it red, yellow, or black. You can match the color to your house perfectly. The most crucial point is the weight. This fraction is very important. The new panel is 1/25 the weight of an old silicon panel. Imagine a heavy, thick dictionary. Now imagine a single piece of paper. That is the huge difference. You can put it on weak roofs. You can even put it on a simple plastic tent. It won't break the structure. Let's look at exactly how thin it is. It's only 0.031 millimeters thin. To put that into perspective, this is like a piece of plastic wrap from your kitchen. It's almost too thin to see from the side. But this thin plastic film catches the sun, and it can power your computer. Here is another amazing fact. It makes electricity from normal room lights. Old panels need bright outdoor sun. They need a lot of light to wake up and work. But perovskite panels can work with just 200 to 1,000 lux. This means you can put them inside your house. They can power your wall clocks and smart home sensors. You will never need to change those batteries again. Section 3. The big weakness. So, we must ask a simple question. Is this new technology perfect right now? Does it have any hidden problems? The answer is no. It's not perfect yet. In fact, this special crystal hates water. It also hates high heat. If it gets wet from rain or humidity, the crystal breaks down quickly. Then the power stops completely. Old silicon panels last for 20 years outside, but early perovskite panels only lasted for a few months. This is a very big problem for companies to solve. So, how do companies fix this water problem? They use these simple steps. Step 1, they print the thin cell. Step 2, they cover it in a very strong plastic film. Step 3, they seal the edges tightly. This way, water cannot get inside the film. Many companies are working very hard to make these strong plastic covers. They really want to make these panels last for 20 years.
Section 4. Japan's secret advantage.
Look at the global iodine reserves. Iodine is the main ingredient for this special crystal. And as you can see, Japan controls 78% of the world's iodine. Japan doesn't have to buy this important material from other countries. This gives them a very big secret advantage. There is another big benefit for making them. Look at the factory heat. An old silicon factory needs 1,400 degrees Celsius. That melts the hard rock, but it uses a lot of energy. A new perovskite factory needs only 100 degrees Celsius. You can use simple, small heaters. This uses much less energy. It reduces CO2 gas, and it helps protect the Earth.
Because of these advantages, many Japanese companies are working hard together. Sekisui Chemical makes the strong, flexible films. Panasonic puts the new cells inside glass windows for tall buildings. Toyo Inc. makes cheap, transparent parts. And Ricoh uses inkjet printing to make the cells very fast. They want to start selling these very soon.
Section 5. The Global Solar Race. And this brilliantly illustrates the global competition. China and Japan have very different strategies. China wants fast, mass production. Their goal is to make millions of panels quickly. They are building huge factories right now. Japan wants to focus on high-tech materials. Their goal is to make very strong films and high-quality parts. Both countries are working very hard to win this new market. Scientists are also trying a clever new trick. They put the new perovskite panel right on top of an old silicon panel. Together, they catch different colors of light. This number, 32.76%, is absolutely amazing. It's a new world record for efficiency. This team of panels makes more power than any single panel before. It's a very smart combination.
This brings us to the big dream. You can put them anywhere. Because they're light, thin, and colorful, you can wrap them around tall office buildings. You can put them on the roof of an electric car. You can even put them on your clothes or your backpack. Soon, every building and car can become its own power plant. We have learned a lot today. This printed solar panel will truly change our world. It will make clean energy easy to use for everyone. So I want to leave you with this interesting question. Think about your house, your work, or your car. Where will you put your first printed solar panel? Thank you for joining me on this explainer, and I hope you keep learning.